everyone, myself Heming Satvara and I am working in LG Institute of Engineering and Technology. So let us discuss about today's topic. Today we are discussing about the application of diode, which is known as rectifiers. So here we are discussing today rectifiers. Let's start with block diagram of unregulated power supply. Here this is the block diagram of rectifier and filters. Now our main aim is to convert AC waveform to DC waveform. So here some electronic device need to DC voltage for their operation. The DC voltage is obtained from the AC mains. So we can see here we are using transformer, then after rectifier, and then finally we used filter. So what is rectifier? Rectifier means it converts AC to DC, right? So this is the first step of conversion of AC to DC. Then after we have to do filtration of that waveform. So here this is the unregulated power supply for the process of AC to DC. So for that we have to enter input in the form of AC waveform. As you can see here, first step to enter input in the form of AC waveform at the AC mains. Then after it goes to the step down transformer. Step down transformer, there are two types of transformer, step down and step up. Step down, that means it lower your voltage level. So here we can see the output of step down transformer. Then after it goes to the rectifier. So what is the work of rectifier? Rectifier are different types of, first half wave rectifier, then after full wave rectifier. It can rectify the signal in the form of this. Here we can see this is the rectified output voltage. Then after, in this manner we have to convert this waveform into straight line. For that we have to use filter. So this is the final process of AC to DC conversion. So in this lecture we are discussing about only rectifier. So you can see in this block diagram the block of rectifier. So next let us discuss about polarities of transformer voltages. How transformer maintain its waveform. So here for example I applied positive waveform. So that means your polarity is plus and below minus. So L, that means it is line, and N, that means neutral. Always current flow from line to neutral, or we can say live to neutral. So here if we entered positive waveform, that's why here we can see the polarities plus and minus. So your final transformation is like this. If you enter positive, so then you will get positive at the output side. If their waveform is changed, like if there is negative waveform, like we can see in this graph, negative waveform, that means your polarity is changed. That means below is plus and above is minus. So always current flowing from plus to minus in this manner. So here we can see always current flow plus to minus. Similarly, that polarity is applied to the second core, okay, or we can say second winding, secondary winding. So same polarity, that means whatever you entered in your input side, you will get same in your output side. If you entered negative waveform, that means you will get negative waveform from the output side. So this is the basic fundamental of transformer voltages here. Now next let us discuss about rectifiers. What is rectifiers? Rectifiers are divided into two types, half wave rectifier, then full wave rectifier. So full wave rectifier is divided into two types. full wave rectifier with center tapped transformer, then bridge wave rectifier, or we can say full wave bridge rectifier. So this is the tree of rectifier circuit. So in this lecture, we are going to discuss about only half wave rectifier. So let us discuss about half wave rectifier. So this is the circuit diagram of half wave rectifier, in which we connect or we used transformer, which is step down transformer, one diode, PN junction diode, as we discussed earlier lectures, then last resistor. This resistor is known as load resistor. So here we can see across the load resistor we will get line or load voltage. So this is the circuit diagram of half wave rectifier. In this circuit diagram, diode is main component because diode works as a forward bias and reverse bias. According to this region, we can get waveform from output side. So let us discuss about its output and input. If we entered positive, that means positive waveform at the input side, that means its polarity is plus and minus. So always current flowing from plus to minus, like this manner, plus to minus. So diode is in the direction of flow of current, or we can say diode's symbol is in the direction of flow of current. So it works in forward bias. If it works in forward bias, that means it is equivalent to the closed switch. If there is a closed switch, that means current always flow from this circuit diagram. So we will get output voltage according to the input. So here diode works in forward bias, thus closed switch, or current can flow from this circuit diagram. So let us discuss about its waveform. Here we can see this is the waveform. Here first we entered input voltage in this circuit diagram. Yes, here we can see at the transformer side plus to minus we entered input, then after at this side we will get output. So here this is the x axis, which is denoted as time, and at y axis, which is denoted as voltage, or we can say current. So if we entered waveform like this is positive waveform, we will get similarly in the output side, because here it works as a, here we can see in this circuit diagram, it works as a closed switch. That means current always flow from plus to minus in this circuit diagram. So we will get same as a input. So 0 to pi, and we will get same output 0 to pi. Now let us discuss about another waveform which is positive. Similarly, we will get from the output side. So this is for the closed loop circuit, or we can say this is for the positive half cycle. Whatever you applied in the input side, you will get similar from the output side. So this is the waveform of closed loop circuit. Now if you are applying negative waveform, let us discuss about negative waveform. So half wave rectifier for negative half cycle, open circuited. Why? Because current always flowing from plus to minus. Here we can see in this circuit diagram, current flow from plus to minus. That means current flows the opposite direction of symbol of diode. That means it works in open circuited, or we can say it works in reverse bias region. So that means it is equivalent to the open circuited. So current flows in this direction, but due to this it works in open circuited. So if there is a open circuited, so current can flow in this circuit diagram. So we will get nothing from this input waveform. That means, so let us discuss about, so if we entered 0 to pi positive waveform as we discussed earlier operation, so we will get similar from the output side 0 to pi. Then next, if we applied negative half cycle in the input, so due to this, here we can see 0 from output side because there is a open circuited, and due to this open circuited, current can't flow in this circuit diagram. So this is the pi to 2 pi, or that means diode is off. Obviously diode is off because of open circuited. Again, if we applied positive waveform, then from output side we will get same as the input, but we applied negative, that means 0, and at that time we will get positive waveform, that means diode is on. So here we can see diode is on. So this is the overall waveform for input to output for half wave rectifier. So here one question may arise, why it is known as half wave rectifier. So we can conclude from this waveform, from the output side we will get half wave only. That's why it is known as half wave rectifier, because we will get only positive side in this waveform. So that's why it is known as half wave rectifier circuit. So here diode is off. So let us discuss about some more things for this circuit diagram. If here we measured across this diode voltage, so what will be your voltage at the diode side? So as we discussed input to output, if you entered positive waveform, then you will get similar from the output side. If you entered negative waveform, then you will get 0, right? So 0 to pi positive, pi to 2 pi is 0, right? But if you measured at the diode voltage, so what will be there? Here we can see this is the diode voltage. It will be 0.7 voltage if you are going to measure at the diode side. So it will be 0.7 due to closed loop. If you measured at the for the negative half cycle, then it will be same as the input, because for reverse bias it will be open circuited. Diode always works as a open circuited. That means there is your input measured from the output side. So here again, if you entered positive, then you will get 0.7 voltage across the diode. So that's all for today's lecture. Thank you. That's all.